Hello, calculus students. We're going to be talking today about topic 7, which is about particular solutions for differential equations. So how many sea lions are on Elliott Bay? The number of sea lions on Elliott Bay on the Pacific Northwest coast is startling to many scientists. Let S of t represent the number of sea lions in a population at any time t, when t is greater than or equal to 0. It is known that the derivative of s with respect to time is equal to 2/5 times 800 minus s, where s is the number of sea lions in a population. At time 0, there are 500 sea lions on Elliott Bay. That is a critical piece of information. We also need this equation. We need to know that t is always greater than 0. So those are the things in that caught my attention. And so how is the population of sea lions changing over time? So when we look at the population changing over time, that's this ds dt. So we're asking you to describe the derivative. So what do you think? Now, just generally speaking, what happens with populations? Sometimes they start slow, sometimes they start fast, but eventually in the middle they get fast and then they have to taper off because the climate can't support so many of them. There's lots of different reasons, but eventually it tapers off. So increasing quickly at first, then slowing down. And then, there should be an and there, and then slowing down, and it maxes out at 800. Amazon dismiss. Okay. When will the populations of sea lion, so the max is at 800, and that's because of this right here. This 800 take away s is telling me the population is maxing when it gets to 100. 800. When will the populations of sea lions stop growing? And how do we know? We'll stop growing when s equals 800 because ds dt will equal 0 then. So it's going to stop growing then. So let's talk about these two things. Because I look at this and I think, well, it's a line. It has a constant, but it doesn't have a constant rate of change. So my brain wants to think line, constant rate of change, not line. So it's the rate of change is 2/5 times this number, and this number is changing. When we start, we've got 500 here, 500 minus 800, so 300 here. And so it's growing really quickly at the beginning. But as this number gets larger, this quantity gets smaller, and so it slows down. So it starts out really quickly, and then eventually, as s gets larger, this gets smaller and smaller, closer and closer to 0, closer to 1, closer to 5, either way, this making this smaller, okay? And so that's what's going on there. Write but do not solve an integral expression that gives the amount of sea lions on Elliott Bay after X years. They ask for this all the time on the FRQs. It comes up constantly. So write but do not solve. So I just pay attention to that phrase, write but do not solve. Okay, and then it tells me an integral expression. So I'm going to make an integral that gives the amount of sea lions on Elliott Bay after X years. So that's where this is going to come into play. At time 0, there are 500 sea lions on Elliott Bay. So time 0, 500 sea lions. So there's my condition. That's where this last sentence is being used. Time 0, 500. And we're going to go from 0 to, it says X years. So this is going to be X at the top. And inside we'll have S prime of t dt. Okay? And this is the number of sea lions on the bay after a certain number of years. Okay? So think about if we were to take the derivative of this, we would get s of t, s of x inside. And since s is the number of sea lions in a population, what's going on? We've got to take the fact that there were 500 when we started counting. Okay? So that's what's going on here. Okay? So they ask for this constantly. And s prime of t, well, very closely related to that. We can't integrate this with respect to time. So it's important to kind of remember that this is not s prime of t. This is the derivative of s with respect to time, but it's not of t. So we'll get back to that. Because we need to figure out what s of t is, and so integrating this is very difficult. Actually impossible, because our equation is not in terms of t. All right. Let's see if we can come up with a specific solution for s. We're going to take our differential equation, ds dt, which is equal to 2/5. 800, take away s, okay? And we're going to try to separate our variables. So I'm going to multiply both sides by dt. ds will equal 2/5, parentheses 800, take away s, dt. dt and ds cannot be in the denominator. So as we separate things, we're going to get fractions all the time. ds and dt don't go in the denominator. I cannot make this point any clearer. I don't know how. Okay, so make sure. All right, here we go. So I need to move this over there. And so remember, I can divide. It's the easiest way, dividing and multiplying are my two things, because it's got to stay as a group. So I will end up with ds over 800 minus s equals 2/5, because again, the less that's with s, the better, dt. So there I've separated. Now we're going to integrate. So integrate both sides. The integral of ds over 800 minus s equals 2/5, the integral of 2/5 dt. Okay. This side is 2/5 t plus c. This side, since this is in the denominator, there's nothing squared here. This is ln, absolute value, 800 take away s. Because when the population exceeds 800, this will be negative. We can't take the natural log of a negative number. Therefore, the absolute value is there. Okay. So we have integrated both sides. Done. Okay. Hang on one sec. I integrated this wrong. Times the derivative, and then I need to take the derivative of the inside. The derivative of negative s is negative 1. And so I need to divide by that derivative, which in this case is the same as times t, so that's why it's negative. I had a tough time realizing. I was looking at the answer going, okay, I forgot something, but why is it negative? So it's negative because the derivative of the inside is negative 1, and I need to divide by that derivative. Okay. Now we're going to show these. We're going to solve first this c. Okay. So we're going to take our initial condition, which we used up here, but now we're going to use it again. At time 0, there are 500 sea lions on Elliott Bay. So t of 0 s of 0 equals 500. That's what that means. Okay. So we're going to go ahead and plug in 0 for t equals 0, s equals 500. That's what that means. Okay. So use the initial condition to solve for t. So we're going to get negative ln of 800 minus, and I didn't want to do that in that color. Not that it matters, but it matters to my brain. Minus s is 500. Equals 2/5. times 0 plus c. So over here, we end up with negative ln of 300. I can drop the absolute value because that's a positive number. So that's why the absolute value just kind of fell off. I don't need it because it's positive. Okay, equals c. And so I'm done. That's easy. No big deal. So we separated, we integrated, we found c. Notice we found c before we got s alone. It is easier to find c right now. Okay, sometimes, and sometimes it's not, but we're going to go with, yeah, find c right away. Isolate s in my equation. So now I'm going back to the green equation. Negative ln of 800, take away s, equals 2/5 t plus, it's going to be minus, but minus the c value, plus c, and c is negative ln 300. Okay. So what I'm going to do is I'm going to get rid of this minus sign. I'm going to make that positive, this negative, and that positive. Will make it easier to solve. Then I'm going to make both sides the exponent of e. That's weird, but if I make e the base and these both become exponents, so keep in mind the inverse of natural log. The inverse of natural log is e raised to something. So to undo natural logs, we make these powers of e. To undo e, we take the natural log of it. It's just an inverse function. It's just an inverse function. It's just an inverse function. Okay, so we end up with 800 minus s, and that's plus or minus because of the natural, it's 800 minus s. 800 minus s. After making both sides e, this cancels out, and I'm left with this. Since it's that absolute value, put the absolute value back. This side becomes e to the negative 2/5 t plus ln 300, right? So to get rid of the 800, the absolute values, I'm going to just write 800s minus s equals plus or minus. That makes the absolute value go away. Plus or minus. E to the negative 2/5 t times e to the ln 300. Because, since I'm adding, I can separate it as the same base with multiplication. Because I add the exponents, that's the rule. I can separate this way. Okay, so that becomes 800 minus s equals, the e raised to the ln 300 is 300. So plus or minus 300, because this becomes 300. 300 went in front, because it's easier that way, times e to the negative 2/5 t. See why it's nice to kind of clean it up here? All that stuff weird with the c, where the c kept changing when we were not finding the particular solution, kind of goes away, which is great. And so I'm here to get us alone. I'm going to subtract 800 from both sides and change the signs. It's going to be a little bit weird. So we'll go slow. Negative s equals negative 800 plus or minus 300 e to the negative 2/5 t. Change all the signs. S equals 800 minus or plus, which is totally lame because it's still plus or minus, but it's minus or plus now. I changed all the signs. So this is stupid, but I wanted you to see that the signs changed, so I'm going to switch it back. Okay. How many possible equations are there for the sea lions at Elliott Bay? 2. I mean, there are many possibles, obviously. How many possible? There's 2. But this shouldn't happen. but this is not reasonable. Only one model can describe population. That's not how you spell population. Of the sea lions. Now, which one should it be? Should we use the plus or the minus? So the part here that needs to be also decided is that we've got to figure it out. So I just want to kind of go over what we did, and then we'll do our final rundown on the next slide. So first we separated, then we integrated, then we solved for C. So we separate, integrate, we solved for C, then we isolated, and now we're on select. So now we have to pick one. Usually we pick one. We don't usually have two final answers. We almost always pick one. So should we pick 800 plus this number or 800 minus? What do you guys think? Well, it's very simple. S of 0 is 500. So which one satisfies that? So remember that when I plug in 0, I'm supposed to get 500. So I'm going to go ahead and plug in 0 to my positive. So I'll get 800 plus 300. E to the 0 is 1. So 800 plus 300, which is not 500. Right? 800 plus 300 is 1100. When I plug it into the minus equation, let me cover it that way. So I plug it into the minus equation, 800 minus 300, e to the 0. E to the 0 is 1. So that one is 500. So that's the one I'm going to choose. And again, I chose that because it satisfies the initial condition. That is satisfied initial condition. I spelled initial wrong. I really spelled it wrong. Sorry. That's how I chose. Okay. Okay. There we go. So last but not least, let's take a look at the particular solution. The words. Let me bring this to the right place. Topic 7.7, finding particular solutions with initial conditions. Some particular solutions cannot be written explicitly and must be defined by integrals. So if dy dx, if dy dx equals f of x and f of a equals y of 0. So f of a just meaning that some initial condition was given. We have some context. In our case, at time 0, when we start counting sea lions, there were 500. In this case, just random number letters. Then f of x, capital F x, this is the antiderivative of lowercase f of x, is equal to y sub 0 plus a, the integral from a to x of f of t dt is a solution. And so that's when it says, hey, write me, but don't solve. That's where we're at. Okay. Finding particular solutions requires 2 extra steps from finding general solutions. So our general solutions, we separate, integrate, and isolate. For our particular solutions, we separate, integrate, solve for C, isolate, select. Okay, so remember SISIS. I don't think that's helpful, but separate, integrate, isolate, we add in, solve for C, and select. Now, honestly, it could be separate, integrate, isolate, solve for C. I like to do it before. It just makes it a lot easier. So it's up to you. And that's where it is. We'll go ahead and leave this here, and we'll talk to you guys soon.